Hi Algebra 1 students. This video is on solving systems of equations using algebra, and specifically we're going to be thinking about this method called substitution. And you may have heard of this before, but we're going to do one easy example and one medium example. So example 1, y equals 2x plus 1 and x minus y is equal to 7. So this is a system of equations because it is two different equations, and we're holding them both to be true. So we're thinking about this as like an and statement. So the idea in substitution here is if you have one of your variables solved for, like in this one we have the y equals, the y is solved for, then you can plug in what y equals, that 2x plus 1, we can plug that in for the y in the second equation, because the first equation tells us that y is equal to 2x plus 1. So if we're holding both true at the same time, that means we can plug this in. So this would then look like we start with x minus y is equal to 7. Now I'm writing x minus, I'm going to be substituting something in that spot where the y was. And what I'm substituting in is 2x plus 1. Now this becomes a one variable equation which I know how to solve. I can think about distributing a -1, so I would get x minus 2x and minus 1 is equal to 7. I could combine my like terms and get -x minus 1 is equal to 7. Add 1 and get -x is equal to 8, which means if I divide both sides by -1, I get x is equal to -8. Now, I'm not done yet because I still haven't found y, but I do know x, so that's going to be important. Now I can take that x value and plug it into either of my two original equations to get a y value. And the equation that's going to be easiest to plug into is the first one. So I'm writing y equals 2x plus 1, and then I'm going to replace that x with the -8. So now I get -16 plus 1, which is -15 for y. And now I am done solving the system of equations because I have a value for x and a value for y, and I can write my solution as the ordered pair -8, -15. Okay. So now we're going to look at a second example, and this example is not already going to have a variable solved for. So that means we're going to have to solve for x or y first. So this example is 3x plus 4y is equal to 12, and 2x plus y is equal to 10. And I put these kind of like squiggly brackets here to kind of group the two as a system. So that's kind of like giving us our system, telling us that this is like an and statement. Okay, so here I don't have y or x already solved for, but I'm kind of looking at my two equations, and there's a variable that's easiest to solve for, and it's this y in the second equation, because that y doesn't have a coefficient in front of it. So it's going to be easier to solve for this variable than any of those other variables. So I'm going to solve for y first, but I could have solved for x. It doesn't matter. Just kind of doing what's easiest. Easiest. I don't think that's how you spell easiest. Maybe it's like this. Okay, so 2x plus y is equal to 10. Then in order to solve for y, I would have to subtract 2x from both sides, right? That would cancel that, and I get y is equal to -2x plus 10. Okay, now I can take that -2x plus 10 and I can plug it in for y. Which y? It has to be plugged in for the y in the other equation that I haven't used yet. Because if I just plug it into the same one, then all my x's are going to actually get canceled out. Okay, so now we're going to plug in for y in the other equation. Okay, so what this looks like is I take my 3x plus 4y is equal to 12, and I'm going to replace the y with star, right, what I've kind of boxed here. So that's negative 2x plus 10. From here, I can kind of solve this like I would a normal one variable equation. So I'm going to distribute that 4 in, and I get negative 8x plus 40 is equal to 12, which is negative. Combining my like terms here, I get negative 5x plus 40 is equal to 12. I can subtract away a 40, and I get negative 28 is equal to negative 5x. And divide by negative 5, and x equals, well, this is a fraction. And if I plug that into my calculator, I get 5.6. Okay, so now I found x. And now I can take that x, and even though it's a decimal, I can plug it back in for x in either one of my two original equations. In order to find y. Okay, and just to kind of organize the steps, I'm going to kind of put, so first thing we did was we solved for y. Second thing we did was we plugged that thing back into the other equation. Now the third thing is we're going to get our y value. So I'm going to plug into the first one, just doesn't matter which one. So if I do 3 times 5.6 plus 4y is equal to 12. 3 times 5.6, I'd have to do that all on my calculator. Let's see. I get 16.8 plus 4y is equal to 12. Then I would subtract over the 16.8. And I get 12 minus 16.8 is negative 4.8 is equal to 4y. Then I would divide that by 4. No, 4. And I get y equals negative 1.2. So now my solution is the ordered pair. So my solution is going to be 5.6 comma negative 1.2. I can't figure out how to stop my video.